Welcome to your first video lesson for Applied Algebra and Trigonometry. We'll be discussing section 110 in your book. That's the section on solving equations. When you're working with algebra, perhaps you remember this. PEMDAS. Please excuse my dear Aunt Sally, also known as order of operations. In other words, when you see an expression, how do you evaluate it? What do you do first, second, third? All right, we are going to use PEMDAS. We are going to be using order of operations, of course, because it's a basic principle of algebra. We've all agreed that we're going to do parentheses or grouping symbols and exponents first, then multiplication and division in order from left to right, and then addition and subtraction in order from left to right whenever we see an algebraic expression. Except we're not evaluating algebraic expressions in solving equations. We're doing something a little bit different. In fact, we're almost doing PEMDAS backwards, but not quite. When you want to solve equations, there's a general order that you follow. You don't always use every single step. You sometimes have to go back and repeat steps, and sometimes you have to throw in a little trig in the process of solution, but we'll talk about that later in the semester. Right now, let's talk about the basic ways to solve equations, basic steps you can use. First, you need to remove grouping symbols, parentheses, brackets, and the like, maybe even an absolute value. Next, try to combine like terms. Like terms like, negative 373, 0, that's not going to change much. 1, 4,742.64. Those are all like terms. Why are they like terms? Well, I don't see any variables there. Those are all constants. They have a constant value. Although the terms I'm writing now have different numbers in front of the x, they all have a single x. They are like terms. This term does not have a single x. It has an x squared. This term has an x squared. Looky here. Let's make this a negative 5x. Okay, if you notice, these two terms both have negative 5. They both have x in them. But one of them is an x squared terms. These are not like terms. They are not like terms. Okay, let's get rid of those two. Okay, what are some like terms to that x squared? Well, like I said, negative 5x squared is like the x squared. 3/4 x squared is like that x squared. So you're looking for variables of the same power. You may be looking at more than one variable. Here are two more terms to consider. 3xy squared and negative 3x squared y. Are those like terms? Yes, they both have x's. Yes, they both have y's. Yeah, they both have 3's. One of them positive, one of them negative. They are not like terms. But why are they not like terms? Because the variables have different powers. If we made the x in the first term squared, and we made the y in the second term squared, those are now like terms. 3x squared y squared is like negative 3x squared y squared. It has nothing to do with the 3 and the negative 3. It is simply the powers of the variable that matter. And if we happen to combine those two, 3x squared y squared minus 3x squared y squared will give us 0. So I did all of that just to give you examples of like terms. However, right now I'm talking about combining like terms on each side. So if there are like terms on the left, combine them. If there are like terms on the right, combine them. To work with like terms on opposite sides of the equal sign, we have to remember one more thing. I call it the golden rule of algebra. I will be constantly reminding you of the golden rule of algebra. Do unto one side as you would do unto the other. Actually, we should modify this a little bit. Do or undo unto one side as you would do or undo unto the other. What do I mean by that? Well, if you have simplified your original problem to the point where you have maybe something like this, 3 plus x equals 10, well, there are like terms, but they're on opposite sides of that equal sign. So in order to get them on the same side so we can then go back and combine them, go back to step 2, we're going to have to undo what is written there. This is a positive 3 plus x, so you're going to undo that positive 3. You're going to subtract 3. You're going to do the opposite, is another way of saying that. And when you do that, subtracting 3 from both sides, because that's the golden rule, do unto one side as you would do unto the other, you're going to get x equals 7. Yes, 3 plus 7 equals 10. It checks. So how do you know when you're finished? Well, when the unknown is isolated, you're done. You are finished. All right. Well, not quite. You have solved the equation. Okay. You have solved the equation. You are not done because I want you to get into a habit of checking your work and showing me that you have checked your work. Because when you're solving equations, you should always know when you've reached the right answer, because it's the only thing that will check in all the equations in your problem. But on the other hand, even though you follow this completely correctly, sometimes you will not find an answer. Let me minimize this even more for now and just push it out of the way a bit. Okay, because I want to talk now about 3 types of equations. Okay, EQNS period equations. Got that? Okay, the first type is a contradiction. It's going to say something that's not, or try to say something that's not true. For example, x minus 1 is equal to x minus 5. Can you find a number for which that is true? No. If you follow the steps, okay, nothing to combine, like terms on either side. Let's follow the golden rule of algebra. Let's get our x's on the same side. Let's subtract x from this side and subtract x from this side, and we get this, which is blatantly not true. Negative 1 does not equal negative 5. Okay? Had we tried to move everything else, eventually we have to get the x's on the same side, and every time we do that, they're going to disappear. So that is a contradiction. It is not true. The second type of equation that you may come across is an identity. An identity is always true, all the time. Okay, so let's write an equation here. 1/3 times 6x minus 6 on the right-hand side, and 2 times the quantity x minus 1 on the left-hand side. That does not look like the same. However, if you go through your steps of solution, remove grouping symbols. Well, to do that, we're going to distribute. That was our first step up here, remember? Okay, and we're going to distribute here also. That will give us 2x minus 2 equals 1/3 times 6x is 2x, and 1/3 times negative 6 is negative 2. Look at that. It's the same thing on each side. That is always true. And if you're just dying to solve this one, let's move our x's to the same side. Oh, look there. The x's are going to disappear again. That'll give you 0 on the left and 0 on the right when we're talking about x's. But you will have negative 2 equals negative true. Well, yeah, that is always true. So a contradiction will never be true. Never true. No matter what value you put in for the variable, it is never going to be true. An identity is always going to be true. It is always true. Okay, but neither of those are particularly interesting. So let's get on to the third type of equation. The more interesting type of equation is a conditional. It is true for some values of the variable. And your job is to find out what those values are. Let's look at, let's do it in this color, 2x minus 4 equals x minus 1. Okay, remember we have to do unto one side as we do unto the other. So let's subtract x from both sides. That will give us x minus 4 equals, that adds to be 0, and negative 1 on the right is all we have. Okay, we're going to undo to one side as we undo to the other. There's a subtract 4 on the left-hand side. We're going to add 4. So x equals 3. Is the x isolated? Yes, we're done. Oh, no, we are not. We need to check. So I'm going to tell you right from the beginning, this is the way I want you to do this. Rewrite the original equation, but put parentheses in for the x. Wherever you see an x, just put parentheses. Don't put your answer in yet. Because sometimes, instead of just writing in a 3 here, because x equals 3 as your answer, you'll have to bring a negative in there. Now we're going to use PEMDAS. We have a multiplication there and then a subtraction. So we do the multiplication first. 2 times 3 is 6. Minus 4 over here. Let's just drop the parentheses now. We don't really need them. And on the left, 6 minus 4 is 2. That is equal to 3 minus 1. That is 2. It checks. And please box your answer so that you and I both know when you're done. We have just solved a conditional equation. And not only is this only true for some values, this is only true for one value, the value x equals 3. All right, let's work some examples. Okay, so let's go with example 1. 7 minus 2t equals 9. Remember, we are trying to isolate the variable. I only have the variable on one side. I'm going to leave it there. Okay? I'm not against solving equations with the variable on the right-hand side, but I'm just going to leave it there for now. I do have a constant on the left side and a constant on the right. I need to get those guys together. So I'm going to do unto one side as I would do unto the other. I have a negative 2t equals 2. Now, I need to isolate that variable. I've moved the constant first. Now I'm going to divide by the negative 2. Why am I dividing by negative 2 instead of subtracting here? Because I want to isolate that t. And negative 2 is multiplied by t, therefore I'm going to divide by negative 2. And I don't want a negative t, so I'm going to take that negative with the 2, dividing by negative 2, as I said. Negative 2 divided by negative 2 equals 1. 1 times t is equal to t. I'm just going to write it like that. On the other side, I have positive 2 divided by negative 2, or negative 1 as my answer. Before I claim that as my answer, though, I'm going to check. I'm going to rewrite the original equation with parentheses for my variable. And now I'm going to put what I believe the variable to equal inside those parentheses. So now I have 7. And look at what I've done. Because I remembered to take the negative with me and put it inside those parentheses, I see that I don't have negative 2 minus 1. I have negative 2 times negative 1, which is actually a positive 2. So 9 equals 9. That checks. It's the same on both sides. And there is my answer that I've boxed. Did you notice the red A in the title of this video? That means there's going to be a B video. So I'm going to end with this example here. Make sure you watch the B video before class as well. I'm going to show you an applied problem because this is applied algebra and trigonometry. So look for the next video.